Okay, it's loading. We'll be streaming soon.
Mm-hmm.
Okay, great. Got it. Now I will just let all the participants in.
Mm-hmm. Mm-hmm. Okay.
Okay, great. I guess everything is working now. So hello, everyone. And we are now starting the 9th Congress of Macroeconomics, organized by the Student Scientific Society of Finance and Macroeconomics at the Warsaw School of Economics and the Institute of Economic and Social Studies. The theme of this year's Congress is Economics and Climate Change. The recently published 6th IPCC report leaves no room for doubt. Climate change will have a drastic impact on nearly all global economies unless action is taken now. This is the time to discuss how to incorporate climate change into our economic theories and models, and what steps should be taken to prepare for the upcoming changes. During the 9th Congress of Macroeconomics, participants will have the opportunity to hear from leading Polish and world economists discussions on the future of economic growth, energy transformation, monetary policy, and macroeconomic modeling. Now, I would like to just quickly thank our patrons, the European Parliament, the Director of the Warsaw School of Economics, the Marshal of the Mazowieckie Voivodeship, the National Center for Research and Development, Polish Economic Society, Polish Economic Institute, Student Scientific Society of Econometrics, Obserwator Finansowy, and Magiel for their patronage. Now, without further ado, I would like to introduce our keynote speaker, Professor Steve Keen. Professor Keen is Honorary Professor and Distinguished Research Fellow at University College London and one of the world's leading critics of mainstream economics. He was one of the handful of economists to realize that a serious economic crisis was imminent and to publicly warn of it from as early as December 2005. More recently, Professor Keen published the appallingly bad neoclassical economics of climate change, which encourages economic forecasting to include the more serious and potentially damaging economic impacts from global climate change. Professor Keen has also developed a system dynamics software, Minsky, which seeks to bring system dynamics modeling into economics. Professor Keen, we are honored to have you here, and we are extremely excited that you have agreed to hold the keynote lecture. So thank you, Professor, once again, and the floor is yours.
Okay, thank you very much. Thank you for the invitation. One of the few advantages of our situation with COVID, of course, is that I'm actually giving a talk now in Poland, and in 1.5 hours I'm giving a talk in Mexico. It'd be rather hard on the physical world and rather damaging to the physical world as well. But of course there are drawbacks, so I'm not going to see most of you as I start giving this presentation, but let's nonetheless give it a go and see how we go. I'll just actually request, if I start running over time, do give me a warning, because I don't actually get a good visual cues where I'm up in timing terms.
Sure thing, yeah.
Okay. Now, one thing I want to emphasize, I have a new book which is now available called The New Economics, a Manifesto. And that concludes the work I cover here, as well as a lot more, but criticizing mainstream economics on climate change. And the short word here is that what they publish simply does not pass what Robert Solow once called the smell test. And he was invited to speak to the United States Congress after the 2008 crisis began, given the fact that economists had failed to see it coming. And Congress wanted to know why. And Solow, who of course developed the growth model that, he developed the growth model subsequent to Ramsey's growth model, but it was the accepted growth model between the mid-50s to about the mid-80s in economics. So he's somebody who is right at the core of neoclassical economics. And what he had to say about neoclassical economics in the late 2000s was that it doesn't pass the smell test. He said the popular DSG models do not pass the smell test. I said they take it for granted that you can have the whole economy as a single consistent dynasty, carrying out a rationally designed plan, disturbed by unexpected shocks, but adapting them in a consistent way. And this doesn't pass the smell test. And this is the protagonists claim that you have to do something like this to build macroeconomic models. You must build macro on micro. But he said, I think this claim is phony. And he said the advocates believe what they're saying. And there's no doubt the same thing applies in climate change, but they seem to have stopped sniffing or to have lost their sense of smell altogether. And a thoughtful person looking at what the economists are arguing might reasonably wonder what planet he or she is on. And that applies in spades to the work that they've done on climate change. So I want to go through three very recent papers, literally since August of this year, published by economists on climate change. So this one was supposedly assessing the economic impact of tipping points and published in the very prestigious Proceedings at the National Academy of Sciences journal. This one was published in what's supposed to be a cross-disciplinary journal on both economists and scientists publishing in climatic change, talking about global warming of between 1.5 and 4 degrees above pre-industrial levels. And this paper is published in Energy Economics, which is edited by Richard Toll, whose name will turn up occasionally in the next few slides. Long-term macroeconomic impacts of climate change, a cross-country analysis. Now, all of these papers talked about 4 degrees or more of global warming, and all of them portrayed 4 degrees as causing relatively minor damages to the economy. So, for example, in the paper on the macroeconomic projections, they said an increase of global temperatures of 0.04 degrees Celsius per year from 2020 forward, so 3.2 degrees more than today by 2100, which is about 4.5 degrees above pre-industrial temperatures, will reduce real GDP per capita by 7.22% by 2100, which is trivial. That's about less than a 0.1% fall in annual growth, in annual per capita growth. You couldn't even measure it with the accuracy of economic statistics, even though the authors provide the figure to 2 decimal places. The tipping points paper said that tipping points will reduce global consumption per capita by 1% at 3 degrees of warming and 1.4% at 6 degrees of warming. And the paper, the survey paper, says mean losses will be 3.67% at a 4 degree temperature increase. Now, this is consistent with economists have been arguing for the last 30 years. So if you take a look at Northhouse back in 1991, he said that a 3 degree rise in temperature will cause about 0.25% fall in output, and you might, by fudging it a bit, get it to 2%. That's no more than an informed hunch, Northhouse said. And in 2018, so virtually 30 years later, with his much more developed DICE model, the damage equations assumes that damage is at 2.1% of GDP at 3 degrees warming and 8.5% at 6. Now, on planet Earth, scientists are terrified by the thought of 2 degrees of warming. This is Hansen, who's with one of the scientists who first raised the alarm about how dangerous global warming was appearing to be. 2 degrees could be dangerous. Stefan in 2018, 2 degrees could lead us on the road to what he calls a hothouse Earth, where after you hit 2 degrees, you roll on to 4, 5, and 6 and basically destroy life on the planet. Lenton said that tipping points could be exceeded even between 1 and 2 degrees Celsius, let alone the 4 to 6 degrees that the economists are talking about. And this is a little map, which I'm going to come back to this later, but the one in the bottom shows Stefan's idea that we have, here's the usual cycle that the planet travels between glacial and non-glacial periods. We mainly have been falling into glacial periods, so human society evolved during an interglacial period where temperatures were higher than normal. But then we would normally roll back here again, but given what we're doing with the human industrialization, we've pushed the climate system over here. And if we tip over here, we could fall into a hothouse Earth. What we should really be trying to do is to move over here. And the worry that Stefan put there was that there'd be 2 degrees would cause this sort of collapse, anything more than 2 degrees. And these are all the various major tipping points that they were worried about could cause a cascade into a hothouse Earth if we weren't as careful. So the scientists are pretty much saying, don't let us get anywhere near 2 degrees Celsius. While the economists are saying that 4 and 6 degrees will be pretty trivial. Now, finally, scientists realized for a while that there's what they called a huge gulf between what climate scientists know about tipping points and how economists represent them in economic models. And Lenton and Sisko wrote back in 2013 that you cannot rule out tipping points even at low, 2 degrees or less increases. But the dominant framing by economists is tipping points only occur at 4 or even 8 degrees Celsius. In 2021, Stern and Stiglitz have realized that there's a huge gap between what the scientists have to say. And they said, well, are the scientists being sloppy? Are they just being sentimental about losing a few penguins and polar bears? Or is there something that the integrated assessment models that economists have built have left out? Well, it's overwhelmingly, indisputably the latter. Only economists can claim otherwise. So the point I want to raise for you today is how on earth did economists conclude that a 3 to 6 degree increase in temperature would only have trivial impacts upon the economy? Well, what they've done is build elaborate econometric models on empirical garbage. And this is I'm going to focus mainly on this paper by Deets and al, where they concluded that a 6 degree increase in temperature, which triggered all these tipping points, would reduce global income by a mere 1.4%. Now, the tipping points they were looking at were the Arctic summer sea ice, Greenland, West Antarctic, the Atlantic meridional overturning circulation, which is colloquially known as the Gulf Stream, which is what kept Europe several degrees warmer than it would be without the heat transfer that AMOC causes from the equatorial regions to the north of the Atlantic, the Amazon, the Indian monsoon, which we've driven into overdrive, permafrost, so all the permafrost in the tundra areas would be gone, according to their modelling here, and even ocean methane hydrates, which is methane stored under great pressure at great depths and kept there by cold as well as pressure. And if the temperature rises, then these huge amounts of methane locked in the ocean floor could rise to the surface. Now, all of those, they're saying, if all of them go, so goodbye the Arctic, goodbye to Greenland, goodbye to West Antarctic, goodbye to the thermohighland circulation, goodbye to Amazon, goodbye to Indian summer monsoon, or rather make it crazy, goodbye to the permafrost. And the scientists didn't include methane hydrates because they didn't think they'd go before 2100. So these are the enormous changes to the planet that the economists are saying will cause trivial changes to GDP. So how the hell they do that? Well, and then it's just to show you how trivial they made tipping points appear to be. They say that without tipping points, a 2 degree increase in temperature would cause the addition of the tipping points adds an extra 0.3 of a degree to the 2 degrees caused without tipping points. Now, this stinks. There's something crazy, truly crazy about these conclusions. And I want to go back to Robert Solow again as a great, whatever he might be as an economist, I have my positives and negatives about him as an economist. He's a great comedian because he said in explaining why he attacks DSGE models and why he won't even talk with the people who develop those in real business cycle models, he said, well, suppose somebody sits down to you and says that he's Napoleon Bonaparte. The last thing you want to do is start getting and having a technical discussion about the cavalry tactics of the Battle of Austerlitz. If I do that, I'm getting tacitly drawn into the game that he is Napoleon Bonaparte when he's mad. So he says, what I do is just laugh. Now, unfortunately, because economists don't know this, and politicians don't know this about economists. They actually think economists are like Napoleon himself. We have to say, well, how did they reach these results? Well, first of all, Deets and co, when they surveyed the impact of losing these tipping points on the climate, they only surveyed work by economists. So they said, climate scientists have often talked about the importance of tipping points, but except for a few fragmented studies, climate economics has ignored them or treated them in a very stylized way. We provide unified estimates of the economic literature, not the scientific. We read what economists had to say about tipping points and found 52 papers that modeled the consequences. And they said, well, there's one weakness we'll admit to, and that is we didn't have non-market damages. We only looked at things which are measurable, things which are bought and sold. But they took precaution, and this sort of shows the level of care that economists apply in climate change. They included an estimate just to check their estimates of market damages. They included ones for non-market as well. And what they did was they used the idea of willingness to pay. Now, if you've done any work in cost-benefit analysis, you'd be aware that willingness to pay is used to assess the value of some non-market goods, say, for example, a nature reserve in the middle of a city versus building an amusement park on that same land. And of course, the amusement park can come up with estimates of what revenue they'll get, so they can value the land as an amusement park. But how do you value the land as a nature reserve when it's free? Well, you ask people what they're willing to pay to preserve it, and that puts a price on it. So they used exactly the same approach to the environment. And what they did, they used without amendment, I emphasize this, without amending the non-market damage module of an IAM called MERGE, which was first developed back in 1995. And that's, of course, is well before economists started considering tipping points. So how can you use a non-tipping point paper to evaluate, as a sensitivity analysis, your work on tipping points? Well, it gets better, because the Deets and all said Merge's method, it's really praising it, places particular emphasis upon the representation of non-market damages with a willingness to pay measure depending on income and temperature. And they then said, while the parameters of the merge non-market damages are speculative. Now that was a red rag to a bull to me whenever I see anything like this. What do they mean by speculative? What do they mean? Well, it meant that Mann et al., the authors of the merge model, made those parameters up. There was no data behind them. If you are going to do a willingness to pay estimate, then you will either use surveys or some sophisticated econometric techniques to assess how consumers value a non-market good. But Mann et al. Simply assumed that the willingness to pay to avoid 2.5 degrees of global warming was 2% of GDP. And that notionally says that 2.5 degrees of warming will destroy 2% of the environment. And they then also, as well as assuming that particular single point, they also said that damages to the environment were assumed to be quadratic. Now, I want to just go back and see how Mann actually justified this. We turn to non-market damages. Few issues are more controversial. Fair enough. That's at least one true statement. How do you value biodiversity, environmental quality, human health? They said, we take an approach based on willingness to pay in the context of how much consumers in each region, and they broke the world into numerous different regions, would be willing to pay to avoid ecological damages. So these are not my damages to the market. The fraction depends both on the temperature change and GDP per capita. And they said, we begin with the willingness to pay function based on the assumption that consumers in high-income countries will be willing to pay 2% of GDP to avoid ecological damages associated with the 2.5 degrees Celsius increase in temperature. Now, how did they justify that assumption? They said, oh, well, there's a point of reference. The United States currently, in 1995, devotes approximately 2% of its GDP to domestic, to environmental protection. So that's one of the two numbers. So having done that and assuming the damages are quadratic, they could then plot this function. Now, why did they assume quadratic? And simple reason, because it's easy. If you have a quadratic, as they say themselves, if damages change quadratically with temperature, all you need is 1 point and you've defined the curve. I mean, if it's working a pure quadratic here, so y equals a some constant times x squared. So once you've said, here's one point on the function y equals a times x squared, you've worked out what a is, and you can draw the entire diagram. So if you assumed damages are quadratic, by the way, this is being referred to in a paper about tipping points, and obviously a quadratic does not have a tipping point. If you'd use that, then you reach the conclusion that the environment will not be destroyed totally until the change in temperature is 17.68 degrees Celsius. And I wish I was joking, but that's actually the number they quote in the paper, both in Mann in 1995 and in Deets in 2021. So that's the quadratic they have for damages to the environment. Damages to the environment is 0.0032 times change in temperature squared. Now, without amendment, this is what Deets and co use, and they repeat the same assumption. This is in a footnote. The delta T cat is a catastrophic warming parameter set to 17.68 degrees Celsius, derived from the assumption that economic losses rise quadratically and are calibrated to 2% at 2.5 degrees warming. This is nonsense. It should never have been published. How on earth can you use a pre-tipping point model as a sensitivity check on tipping points? Well, let's go back and get a hint here. Back to Robert Solow. You're talking to a monkey who thinks he's Napoleon. Okay? And this is just mad. Let's go back and look at that Napoleonic assumption in inverted commas, because Napoleon wasn't this stupid. How they say 2.5 degrees Celsius means 2% damages. Well, that's the end, repeating this whole thing. They took the data back at the time, said, well, that's 2% is what America's spending on environmental protection. But that's, and let's repeat this yet again, just to emphasize the point. So that's how they got their 17.68 degrees for total destruction of the environment. But that's just using the percentage of GDP from 1992. They should have also used the change in temperature in 1995. It's the data they used actually came from 1992, but 1995 was when they were published. So let's say delta T in 1995 was 0.5. Pretty close, that'll do. Okay, so let's now do, what's the quadratic that passes through not 2.5C and 2%, but 0.5C and 2%? With quadratic damages assumed, of course. Well, you now get, rather than 0.0032, you get 0.08 times change in temperature squared, and there's your prediction. The environment will be totally destroyed at 3.54 degrees Celsius above pre-industrial levels. Now, that's still a crazy number, but it's much closer, or the function is crazy, but it's still close to what scientists actually think. Yes, most economists scientists say, yep, hit 3.5 degrees Celsius, there won't be anything resembling the Holocene climate left. We'll be in a climate that is inhospitable for the animals and the species that evolved in that climate, which of course includes human society. So again, as I pointed out earlier, a quadratic doesn't have a tipping point. A tipping point implies a change in the rate of change of the process at some point, an abrupt change or a very fast acceleration. So if you want to do this with a simple function, the easiest one is a logistic. And if I calibrate this to have the same catastrophic level of 3.54 degrees Celsius, but also pass through that 0.5 and 2% number, then this is the curve that I get, this blue line here, which gives you very low damages out to 1, 2.5, and even you got to get out to 1.4 degrees to get 10% damages, whereas the quadratic at that point is giving you about 18%. This is the quadratic Deets and course should have used. This is the one they actually used. Absolutely trivial. So it's a simplistic way of improving what they're talking about to use a logistic rather than a quadratic, but at least it carries the warning, don't let this get too much momentum, and you'd be best off to stop well short of 1.5 degrees Celsius. And we're currently here. We're not too far from the 1.25 mark when things start to really take off on the 1.5, where the momentum could be so great we get wiped out. So what we need is a science perspective on what to do, not what the economists tell us. And the scientists are saying we need urgent action right now. The economists are saying, what's your hurry? So as well as using nonsense to describe the non-market damages, they also use nonsense to describe the tipping points themselves, because out of those 52 papers, they used about 27, I think, in the end, and they used one of them for what's going to be the impact of shutting down the thermohaline circulation, the AMOC, the Gulf Stream. And this is an enormous ocean current, hundreds of times the volume of all the rivers on the planet. And it covers the entire planet. It goes from the Pacific right through the Indian Ocean to the Atlantic. And what you have is warm water flowing from the Pacific, going up to the Arctic regions, getting cooled there, dropping down because of salt differences as well, traveling around back past the Antarctic again, and then back around. And what's going to happen with the AMOC shutdown is that section would disappear. Now, if it does break down, there'll be no change in global temperature, because this is like a conveyor belt changing where the temperature goes. But the equator would be hotter and Europe would be colder. And you could see 3 to 10 degrees Celsius change in the temperature in southern Germany, and obviously also Poland coming out of that. Now, what would actually happen? Well, according to scientists on this, and now I'm quoting Hansen from 2015, and he was just looking just at what might happen at 2 degrees Celsius, not the 6 degrees that Deets and I talked about. You would get a 10 to 20% increase in the speed of winds. And because the power of a storm is proportional to the cube of the wind speed, that'd give you 1.4 to twice as strong level of storms. And that huger temperature gradient could cause superstorms. And the superstorms that they talked about were hurling 1,000-ton boulders 20 meters up the shore of islands in the Atlantic, when this last happened about 120,000 years ago, when the AMOC last shut down. Now, there's recent research saying that the AMOC is slowing down. It's about 15% slower than about 20 or 30 years ago. And the reaction of Richard Toll to this was good. So here are the scientists saying, this is a system we don't want to mess with. And Toll says, good that it's shutting down. That'll improve the economy. Now, why good? Well, Dantoff, Estrada, and Toll, using Toll's fund modeled what they said would happen if the AMOC shut down. And they considered only the impact of the shutdown on national temperatures. So they didn't look at interactions between a hotter equator and a colder north. They just said, well, there's some optimum temperature for agriculture. And if the temperature change pushes you towards or away from that optimum, then you have better or worse outcomes. So the cooling is best seen as reduced warming, and therefore the effects are positive. If the THC, the thermohaline circulation, the AMOC, slows down a little, the global impact is a positive 0.2 to 0.3% of income, or it's 1.3% of income for a more pronounced slowdown. And then they said, of course, we also assume people are going to be richer in 2085. That's when they estimated the changes occurring by. So therefore, you'll be less vulnerable anyway. You know, you're wealthier. Who cares if you have to live beneath the glacier? You're going to be wealthy enough to afford air conditioning. No, it's drivel, complete drivel. But this was reproduced by Deets without any criticism at all, and actually said the AMOC will improve the economy by reducing damages from global warming. And they even, another one of their studies said that losing the Arctic would also be good. So here are their overall, the 8 factors they looked at. And here are the 2 that they said would actually improve the economy if they happen. So let's get rid of the Arctic. Who needs it anyway? What have polar bears ever done for you? Get rid of the AMOC. Hey, you know, we could do with a cooler Europe. This is garbage. This is children playing at being God. And what happens throughout when you look back, this is not a new aberration. This has been going on ever since economists, led by Northhouse, started attacking what scientists and engineers were saying about climate change. So here's Northhouse back in 1991, saying that the sectors which are going to be affected by climate change are those which are exposed to climatic variables. At the other extreme, things which happen in carefully controlled environments that won't be directly affected by climate change. And he said, we estimated that 87% of GDP will be negligibly affected by climate change. And for the bulk of the economy, now look at the industries there: manufacturing, mining, utilities, finance, trade, and most services. It's difficult to find major direct impacts over the next 50 to 75 years. And the IPCC, rather than saying this is madness, repeats the same thing because it's written by the same people. Richard Toll was the second co-editor of this particular chapter in the 2014 IPCC report. Other economic activities, such as manufacturing and services, take place in controlled environments and are not really exposed to climate change. Now, Northhouse mentioned Table 5 and said this is where he had his estimates of what's going to be affected by climate change. Notice you have potentially severely affected farms, forestry and fishing, moderate potential, construction, water transportation, energy and electricity, water and sanitary, some real estate, but negligible impact. Look at that list. All of manufacturing and mining, all of transportation, not all of it, most of transportation communication, all of finance, insurance and real estate not on the coast, retail and wholesale trade, government services, 87% of GDP. Now, the only things those things have in common is they take place either indoors or underground if we're talking about mining. So what he's doing is mistaking the weather for climate. And it took me a long time to realize this is what was going on because it just feels so crazy to say that's what the experts in economics and climate change are doing. But they are literally mistaking climate for weather. They also mistake space for time. So, and one of the other ways they built their empirical estimates was to say that they look at variation in economic activity with climate over space. So what's the GDP in an area, part of America with a high temperature versus GDP or gross state product in an area at low temperature? And they said, oh, that's what happens across space will happen across time as well. That's insane. If you imagine doing from the first principles, a econometric study of what was the impact of GDP on temperature, then you need to break it down into at least 3 causal factors. One is solar cycles, how far we are from the sun, variations in the Earth orbit, all of which are irrelevant on the timescale of global warming. Second is solar energy retention. How much heat are we retaining from this heat that the sun dumps on our planet via additional greenhouse gases? And that's what global warming is about. Third issue, how far you are from the equator, from oceans, above sea level, etc. And that's irrelevant to global warming. Now, their statistics, this cross-sectional approach, as they called it, derives parameters for the third factor and implies those parameters to the second factor, assuming also the second factor is quadratic. Now, this is a bit like having a detailed north-south map of a mountain and then using that to advise people on how safe it would be to cross the mountain east-west in the dark. It's completely irrelevant, but this is what they're advising governments and businesses on. Now, I want to show indicatively what's going on with this so-called cross-sectional approach. This is a chart showing on the horizontal axis how much the temperature in the United States state differs from the average, which is 11.5 degrees Celsius. So that's the XY scatter, the X scatter. The Y scatter is the difference, deviation of gross state product per capita from national per capita GDP. Now, if you look at that, not much of a relationship, but you can fit a quadratic to it, and that's what the quadratic looks like. Now, that quadratic gives you a coefficient of 0.00318. That's pretty close, you might realize, to the number that it was assumed by Mann and co. This is what Northhouse uses for the economy. And that is actually larger than what he uses because the coefficient that Northhouse uses in DICE is 0.00227. So the little black square there is showing what Northhouse's predictions are for a 6-degree increase in global temperature over pre-industrial levels. So this is implying an incredibly trivial impact. 6 degrees increase in temperature, just an 11.5% fall in GDP. And this supports global warming trivializers like Bjorn Lomborg. And this is, to me, an extremely obvious point. If Bjorn Lomborg is using what economists argue to trivialize climate change and to argue we shouldn't do anything, just how are economists exactly helping the world cope with climate change? They're not helping, they're trapping us in a disaster. When they do read the scientific literature, and this is particularly directed at Northhouse, they read stuff that is not there. So notice this table here, which is actually a table from a paper by Tim Lenton, who's now a research colleague of mine and a friend. And in doing this, he was saying, well, the minimum temperature that might chip the Arctic is 0.5 degrees, the maximum is 2, and if it happens, it could happen in a decade, et cetera, et cetera. And the key conclusions that Lenton made in this particular paper was say, first of all, do not use smooth functions to model climate change. He said you might lull us into a false sense of security if you use smooth functions. And the two elements of the climate that are likely to tip this century, and 5 others may tip, the 2 likely ones are the Arctic and Greenland. Okay, and the Arctic may already have tipped at even 0.5 degrees Celsius. I think that's becoming obvious. We're going to lose the Arctic summer sea ice sometime in the next 1 to 2 decades. Now, Northhouse summarized the paper this way. The review finds no critical tipping elements with a tipping time horizon of less than 300 years until global temperatures have increased by about 3 degrees Celsius. That is not what Lenton said, and if any student submitted a paper to me summarising Lenton's paper that way, I would fail him outright, probably kick him out of the course as well. And not only this, Northhouse actually uses Lenton to justify using a quadratic for damages in dice. This is consistent with the survey by Lenton. No, it is not. It is completely inconsistent with the survey by Lenton. So why do economists do this? I think fundamentally it's because they are inherently global warming deniers. They're not deniers in saying it's not happening, but they deny that it matters. And the basic mindset I think that neoclassical economists have is that capitalism is this wonderful system that can cope with anything, so therefore global warming can't be an existential threat. And this is some of the nonsense I've had to read in the last 2 or 3 years while I focused on this particular literature. This is Northhouse in 1991. Human societies thrive in a wide variety of climatic zones. That's true. For the bulk of economic activity, non-climatic variables swamp climatic considerations. True if you're only looking at today, not true if you're looking at changing the climate in the fundamental way that global warming will do. In 1994, surveying so-called experts, he said, a 3-degree warming by 2090, in the words of respondent 17, I'm almost certain that's Larry Summers, that over 3 degrees would be small potatoes. And again, I'm guessing this is Larry again. It takes a very sharp pencil to see the difference between a world with and without climate change or with and without mitigation. So far as they're concerned, it can't have any big impact because capitalism can cope with anything. Therefore, global warming can't be an existential threat. Now, when they do actually confront scientists, Northhouse is forced to admit, yeah, what scientists think is 20 to 30 times worse than what the mainstream economists think. But within economics, they have what they call medium evidence, but with high agreement that climate change will have a small impact on the economy relative to other drivers. So they've got inherently, they're denialists about the worries of climate change. And that's also built into the core model that neoclassicals use, which is the Cobb-Douglas production function. Now, I'm going to quote Larry Summers favorably here because back in 2013, he made a couple of very funny remarks at the IMF forum talking about the financial crisis and saying, I'd make an analogy to it in terms of a power failure. He said, if you had a power failure, there'd be a bunch of economists saying, well, electricity is only 4% of the economy. So if you lost 80% of the electricity, you couldn't possibly lose more than 3% of the economy. And he said, and there'd be people writing papers like this, but it would be stupid. You wouldn't quite know why, but it would be stupid. So I want to show why Larry's right, that this trivializing of energy is stupid. And the standard production function, of course, the Cobb-Douglas, ignores energy. So you have output as a function of technology, capital, and labor. And the exponent for capital is based on its share of GDP, which is about 0.3. Now, when limits to growth came out, economists responded by some of them by saying, well, let's include energy as a third factor of production. And what do you use the exponent? Well, you use the value, roughly the share of energy in GDP, which in this paper in 2016 was set at 0.03, so 3% of GDP. Now, in a paper I wrote in 2019, which I worked out the ideas from 2016, I had a little insight. Labor without energy is a corpse. Capital without energy is a sculpture. So energy is not an independent factor of production. It's an essential input to capital and labor, without which they can't do any work. So you can replace K and L with K as a function of E and L as a function of E. And the functions are basically the number of units times the energy consumption per unit times how much of that energy is turned into useful work. And when you look at the product of the energy consumed by an average worker today, times how much of that energy is used to do useful work, you get a constant. It's roughly 100 watts per hour. Whereas the energy for a machine has been going exponentially ever since James Watt. So when you feed that in, what you find is your EK, your energy input into the representative machine, is raised to the power not of 0.03, but 0.3, which is 10 times the exponent that was used by neoclassicals when they considered it. So what you get is a drastic understatement of the impact of energy on production. And I'll go to Larry's example. Let's say there's an 80% fall in electricity. Well, according to the standard Cobb-Douglas, we use that 0.03 coefficient. That'll cause a 5% fall in GDP. And if you substitute, what that means is fundamentally, you lose the energy, you just use more capital and labor. Easy. Substitution solves everything. But once you say energy is an input, then the result is not a 5% fall, but a 38% fall in GDP. And fundamentally, that's because there is no substitute for energy. If you don't have energy, you can't turn the machines on. So when I graph this and say, what's the impact going to be, while still taking the Cobb-Douglas production function seriously, which I don't, but I'll do it for the meantime, you get this enormous gap between what economists think is going to happen and what would have happened if their model of production was correct. Now, Mankiw, and again, I'm not used to praising Mankiw either, but he did a couple of very good papers back in 92 and 95 using cross-country comparisons to show that the exponent for K shouldn't be 0.3, it should be at least twice that, and preferably he came down saying it should be 0.8. And when you use his recommended level, what you get is a contradiction. First of all, the cross-country strongly contradicts the idea that alpha is 1/3. But he said you'd solve all those problems if you used a larger value. And he said, I'd recommend zero value for capital of 0.8. So if you feed that into my modified Cobb-Douglas production function now and say the alpha is not 0.3 but 0.8, you get the black line. And what that tells you is if you have an 80% fall in energy, then you'll have a 72% fall in GDP, not 5%, which is in the minds of neoclassical economists. So Larry was right, okay? When there isn't any electricity, there's not going to be much of an economy. Now, this is what economists are thinking is that level of change. What's going to happen is that level of change. And it matters because if we're forced just to rely solely upon non-carbon-based energy, we will have an 85% fall in energy input, 80 to 85%. And this is because when you look at how much of what we currently produce in energy is using non-carbon technologies, it's been about 13% for most of history, and only in the last 10 years, 5 to 10 years, have you seen a significant rise. So the potential is if we are literally forced by some catastrophic event to say that's the end of using carbon to produce energy, we've got to use only non-carbon based sources, we'll have an 80% fall in GDP as a result of it. And just to show you how much change in GDP and change in energy correlate, this is looking at data from 1970 to 2014, and the correlation between change in energy and change in GDP, and it can go both ways, of course, is 0.83. So whatever you might think about decoupling at the local level, there's an enormous reliance upon energy for GDP output. So economists have got this completely wrong. They have trivialized the dangers. They've made us led us to doing nothing of significance for 50 years. And in that 50 years, the pressure we've put upon the environment has quadrupled. And therefore, the damage we're doing is that much greater, and the fragility of our social system is that much greater. So what they should be doing is stop trying to measure this. Leave it to the scientists. They tell us 1.5 to 2 degrees is dangerous. Don't go past it. We should simply be working out how do we finance the change. Now, of course, can you ask mainstream economists how to finance something like preventing global warming destroying the economy? Well, no, you can't, because they have no idea about money. They leave money out of their economics. So MMT gives us an idea, and that is that government deficits themselves create money and also create reserves. And the reserves are then used to buy bonds. So there's no problem in a dramatic expansion in government spending when you live in a country which has its own currency, on which note, do not join the euro. And then when you sell bonds to the public, that's not financing government spending, it's reducing private consumption, because you want to take people away from buying, for example, stockings made of silk, so you can use the silk instead for parachutes during World War II. So this is a little, again, I'll come back to this in terms of timing, but just to show you could actually finance the spending we need through deficit spending. You could sell the bonds to the banks, which would buy it because the reserves that they used to buy it were created by the deficit itself. And if you sell the treasuries to the public as well, you're doing it to reduce public consumption of consumer goods, so you can focus all the effort upon fighting climate change. So we need to go back to what we learned from World War II, forget everything neoclassical economics has taught us in the last 70 years, and go back to seeing that taxes revenue are obsolete. We've got a government spend our way out of this crisis. Then make it useful in terms of resource mitigation. Now, again, the aggregate production of function approach which economists have used have blinded them to the importance of resource depletion. And when you look at what actual scientists and engineers look at and say, just how much capacity do we have to change? The answer is pretty terrifying. And there's no way the market can get us there fast enough, because this is looking at the periodic table and saying which of these elements are in short supply. And there are some, including zinc and silver, which are both essential in a large part of manufacturing, and neodymium, which is necessary in current battery technology, where supplies are already critical. We've got every possibility of running out of them in the next century. Phosphorus itself is in limited availability, and you can't have life without phosphorus. We'd have to evolve an entirely new way of processing energy as life forms on this planet to survive a phosphorus breakdown. And these ones are all vital for current technologies. So we have an enormous need to shift, and the shift has to be done at World War II speed, not at the speed a market reform would give you. And there's all this waffle about decoupling. I just want to make a point back to the energy levels again. Yes, okay, there's been some decoupling in some countries and some recent decoupling as well, but the dominant picture is you can't have increase in GDP without an increase in energy. If energy falls, you're going to have falling GDP. So decoupling is a pipe dream. We certainly haven't got time to do it in time to avoid the crisis coming our way. We need a rapid transition to a non-carbon based system. And we also need to ration consumption. Now, one proposal that I've been associated with is using a central bank digital currency with universal carbon credits that are equal to the national average for consumption for a given country. And they're necessary to purchase goods as well as money. And of course, 95% of the population, if you gave universal carbon credits on a per capita basis, 95% would have more than they can use. But the top 5% would need to buy off the bottom 95%. So they'd be politically popular because the majority would be able to sell the excess to the wealthy. 95% of the population would benefit. The market would set the price, not economists, and it would put pressure on the rich to buy and develop low carbon dioxide goods. And it could also be used, if we really did start having catastrophic change, then you could use it as a rationing system when you had this war against climate change, which is what we need to think in terms of. So this is a website based on the idea. And the idea, just to flesh it out a bit more in a bit more detail, you would have. I'm just going to try to get this one here. I think I'm repeating myself there, so I won't go through that in text terms. But the basic accounting is this sort of idea. This is using my Minsky software to try to lay it out. So you'd have workers paying the carbon content as well as the money price of goods, capitalists doing the same thing, but workers would then have excess carbon credits, which they could sell to capitalists. So there would be, you're paying a carbon content as well as paying a money price. And then the workers would sell their excess credits to the capitalists, and there'd be a wealth transfer from capitalists to workers. Now, this is not the first proposal like this. Before I worked this idea out, a guy called Delton Chen had worked out a similar idea called global carbon rewards. And there's also an academic proposal from the UK called tradable energy quotas. So those are two more ideas along the same theme as my idea of tradable universal carbon credits that I'd recommend you to take a look at and see whether you can contribute to those ideas. For economics itself, we have to get away from the fantasy foundations of neoclassical economics. Now, I discuss this at length in my book, The New Economics, a Manifesto. I'll discuss it at much greater length when I finally get to write my magnum opus, but that's going to take me at least 5 years before I probably can start. Certainly 5 years before I finish, maybe 5 before I start. So if you look back and see who actually had, in all the schools of economics, a thermodynamically sensible view of the system of value, it was only the physiocrats. And this is looking at the, I think I'm being told to, let's see. Yes, I'll come back to that point in the chat later, so I'll just take that as a question. Okay, so that's, the statistics said there's two parts of the produce of the land. One goes to subsistence of the farmer. The other goes to the owner, which is a free gift of nature. And that's what we actually base ourselves on. So we need this free gift of nature approach, the fact that we are exploiting free energy as the essential way to found economics, rather than this mythical utility maximization nonsense of neoclassical economics. That ends up saying that your best starting point is actually a modified version of the Leontief production function, where you say output, which when you think about aggregate production functions, they're basically working in terms of a fictional good called a widget. So how many widgets can you produce? Well, that's equal to the energy per year, output as useful work, divided by the energy input into the typical machine. And that gives you this function, the efficiency with which energy is turned into useful work, times the amount of capital. That's basically your production function. What this means is you necessarily have waste. That's your useful work. This is your waste. So from this approach, you integrate economics and ecology right at the ground floor. And that's what we should have done. It's what we have to do to have anything worthwhile in economics in the future. And you can also, as I explain again in the manifesto and a free companion book with it called Modeling with Minsky, you can build macroeconomics from these foundations. You don't need all this neoclassical nonsense of microeconomics. You can go straight from the aggregate level when you respect the fact that you can only have output if you have energy as an input. So mainstream economics has negligently and drastically underestimated the damages we face from climate change. So humanity has delayed any action for far too long, at least 50 years. It's too late for market mechanisms to nudge us forward. It's quite possible we can't even have that adaptation at 1.5 degrees warming. We may need to try to reverse some of the forces that we're now unleashing upon the planet. And we will probably also need wartime scale mobilization of resources and wartime scale rationing as the tipping points start to cascade forward. So economists could help by developing financing and rationing methods as they did in World War II, but it can't be done by the lot who've done mainstream neoclassical economics. These people, Northhouse, Toll, Mendelssohn, Hope, Deets, Wagner, and many others, should be excluded from any future advice on climate change. And neoclassical economics has to go. It simply has to go, because only neoclassical economists could approve the nonsense that these neoclassical economists have used as simplifying assumptions about the danger of climate change. So I hope my audience here can help towards eliminating neoclassical economics before it eliminates us. Thank you.
Well, thank you very much, Professor Keane. That was a great lecture. And now I think we still have quite a bit of time before your another lecture in Mexico.
35 minutes,
yeah, to answer a few questions from the audience.
Sure.
We have, yeah, to the audience, feel free to ask questions in the chat or
I'll answer the one from Julek, which is topic, could industrial policy based on renewables contribute to reducing ecological problems? Yes, it can, but there's also issues of scale. So the paper I linked, and I'll send you a copy of the presentation, by Simon Midshaw, is actually an Australian engineer, mining engineer now based in Finland, argues that the scale, if we wanted to go, say, from all internal combustion engine ICE vehicles to electric vehicles, there isn't enough battery technology in terms of lithium and the other components that go into those batteries at present to enable that to happen. If you want to have off the grid photovoltaic cells, the scale just doesn't work either. On the grid is a different story, but it's still very, very challenging to maintain the level of economic activity you have now with renewables, given the rate at which it takes to open up new mines. It would be necessary to reach the scale of production involved. So, and I'm not going to make a case one way or the other here, but a lot of my engineer supporters very much think nuclear is necessary to have any chance to maintain our current level of industrialization. Jubberg's asked, what are your thoughts on carbon taxation dividend? Too little, too late, and they'll never get done anyway. Carbon taxation, you saw, carbon pricing, you saw what happened in France with the Gilets jaunes when Macron introduced carbon pricing. Carbon taxation and the idea of then a dividend to compensate. Economists have never worked out how to do that sort of stuff. They'll talk about compensating the losers in an academic paper and never get around to doing it in terms of government policy. So I just don't think it would take effect. And economists have failed society? Absolutely. In fact, quite frankly, I think they're guilty of ecocide. I'm looking forward to the crime of ecocide being defined, and I hope to help prosecute the people who've done this for that crime once it becomes part of the law. This is work which, if a doctor had done it, you'd be struck off the rolls and probably put in jail. Hard currency. No, I think this is a case where you need fiat. Okay. Hard currencies, only, if you again look at David Graeber's work, hard currencies have only worked in periods of military breakdown. When you have one country fighting another, you don't know whose king is going to survive, so you insist on payment in gold. So we might well end up in that world, the way things are going. It's a world of Mad Max, and the hard currency might be water, quite possibly, and certainly energy. But no, I don't think a hard currency would solve it. Okay, any other questions?
If you prefer, you can also unmute yourself and ask the question, or you can write it in the chat. Yeah, there is another one.
Okay, market solutions sufficient? No. They could have been 50 years ago. William Northhouse destroyed the credibility of the limits to growth study back in 1972, attacking its predecessor, which was written by one of the world's great engineers, J. Forrester. And he rubbished it. And his point was he rubbished it saying it was measurement without data, and made a great song and dance about how there's not one empirical fact in the book. That was wrong. There was one mistake. They didn't include the empirical work they actually did in the first publication that came out 2 years later. But it was all based on empirical data from 1900 to 1970, and then they ran the model forward from that point of view. And Northhouse completely misunderstood the structure of the model and attacked them for all the things he did himself later, extrapolating 200 years into the future and so on and so forth. And of course, Northhouse made up his own data. So if we'd actually if these people, including Northhouse, hadn't derailed the limits to growth, we might have started doing stuff 50 years ago. And 50 years ago, yes, we could have done with market solutions. It's too late for that. It's going to take wartime levels once we finally realise. And of course, we still haven't realised. You're still having, as Greta put it about what's happening at Glasgow, you still have blah, 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 rather than serious action. And will rising CO2 prices and accelerating deployment of renewables contribute? No, again, it's if you actually put the price on carbon you need to stop this, you'd stop the economy completely anyway. I don't think the market can work anymore. No, we didn't use the market to get rid of Hitler. Okay, it wasn't. We didn't put a good price on his head and let the market take place of the Second World, take part of the Second World War. Same sort of thing here. You need an absolute dedication to this particular issue, as many resources as you possibly, and you command them there. And that's why I think a fiat currency is necessary. Nuclear takes time, I agree, but some of my colleagues working in that area say that with modern technology and without the regulatory overhead for the much more unstable reactors of 40 and 50 years ago, they can actually be pumped out quite rapidly. I know I'm a bit ambivalent. I'd like to see a balance between both nuclear and renewable. But I have to say that the people making the case against the renewables in terms of resource availability and the low density of the energy, they make a convincing argument. Emissions allowance trading, that's partly what the idea of universal carbon credits are based upon. But what you then, you'd be trading, you'd have a hard limit for every country in terms of the amount of carbon dioxide it can emit. Now, I don't think there's any chance to do it at the international level. International agreements by almost guarantee nothing's going to happen because they can never agree. You see it happening at COP26 with idiot countries like my own country, Australia, and Saudi Arabia and so on, blocking any consensus. So you won't get it at the international. You need something at the national level, and an easy way initially would be to say, let's set a quota at the national level per person, equal to the average consumption for that country. That alone would put enormous pressure upon that country's carbon to reduce its carbon load. And because it would be so politically popular for the poor, it could actually spread to other countries that way. So in this particular case, I'd rather work from nations up than trying to do it from the globe down. Best chance of incorporating climate into their models, post-Keynesian economics and complexity theory. So those two areas that I work in. And I've done that with a report I've done for the Rebuilding Macroeconomics in the United Kingdom. The EU seems to be more willing to act. How about China? Problems should be solved globally. They won't be solved globally. I'm sorry, that's naive. In fact, that's exactly what the fossil fuel companies want us to think. You'll see, if you search for a documentary where a couple of investigative journalists con a couple of oil lobbyists in Washington in the pretense that they're actually applying to get them to lobby for them. And these oil lobbyists say that they support carbon taxes because they know they'll never happen. Okay. So equally, supporting global agreements because they'll never happen is a great tactic for the fossil fuel industry. We have to think outside at the national level. Let's see, any changes, economic related chapters to the IPCC? I doubt it. Again, I don't blame the IPCC here. They appoint the recommended people from the top universities. Who teaches the top universities in economics? Neoclassical economists. People like myself don't get a look in at universities at the high rank ones because the neoclassicals, if they see my name on the application, they bring out the garlic and stab the application with a silver sword. So you don't get any non-neoclassicals getting a job there. So the only ones who turn up writing the IPC are neoclassicals, and they won't see any problem with this. Or rather, they'll be intimidated by the peer pressure thing that dominates neoclassicals. So, I mean, why on earth did Deets republish this stuff when all he could bring himself to say was that parameters for the Mann model are speculative? I'm not saying this is bullshit, they were made up and they bear no resemblance to reality. They're afraid to criticize their elders in neoclassical economics. Well, guess what? You should be criticizing your elders in neoclassical economics. Is that about it?
Yeah, there's a few more questions now. Yeah.
It's growing, but growing. So it's the share of renewables energy. Yes, it's growing, but if you extrapolate the current rate of growth in 2010 to 2018, we get to 100% renewables by sometime in 2100. That's too long. We need it to be 8 to 10 times faster than it's currently growing. Central banks are going to have to grow up. I actually I'm actually running for office in Australia at the next election. And one thing I'll be campaigning for is central bank digital currencies. not because they think they're needed for why central banks want them, but because that would be a way of distributing universal carbon credits. Yes, we've got to kick economists out of the way everywhere. And of course, they dominate central banks. So we've got to dominate the central banks ourselves. And big and effective government, I agree, okay? It doesn't happen. But the sort of catastrophe I'm expecting is something like James Anderson was just recently noted as having said back in 2015. And that is that if we lose the Arctic, then what will happen is water will get into the stratosphere in a process which is irreversible. When the water gets into the stratosphere, it breaks down the gap between the Arctic and the equator so that the northern hemisphere will have a pretty much uniform temperature. It won't be 35 degrees all the time in the Arctic, but you'll have the average temperature will be like 22 degrees in the Arctic, and 30, 35 in the equatorial region, and that will destroy agriculture. But it also, as he pointed out, because we have so many chlorofluorocarbons still in the atmosphere, they'll ride the water into the stratosphere and destroy the ozone layer. So it's quite possible we could be irradiated to death by the elimination of the Arctic. Now, that doesn't get into economic papers whatsoever. This is the sort of catastrophe that scientists are worried about. So, we are really in deep shit. And it's time we stop listening to the economists and realize why. Anything on a more optimistic note? Yeah, I've got a new book coming out. Please buy it and bash it over, use it to bash neoclassicals over the head with. Buy the hardcover version, don't use the paperback. Yes, and that's a good one by Nathaniel Rich, and there's a new paper by Ben Franta as well. Ben's done a brilliant piece of work on how economic consultants have also used what economists put out to slow down action on climate change. So that's a good recommendation. If that's okay? I think that seems to be, I better go because I've got half an hour before the next talk. So
right, okay.
I'm sorry, I'm a cheerful bloke for giving a depressing message, and I blame neoclassical economists for that, and I intend getting even.
But you're doing a good mission here. So we're very glad you have agreed to hold the keynote lecture. I think that was very sobering, as Piotr has answered, for all of us. So yes, thank you once again.
You're welcome.
Thank you from all of us, from the whole audience. And well, yeah, let's hope that something will change for the better, maybe in the near future.
The demonstrations that are happening in Glasgow now should be happening in neoclassical economic lecture theatres.
Yes, exactly.
Get in. And I'm speaking as somebody who did it myself when I was your age. So get in there and do it. Give them hell, because they're creating hell on earth for us.
Right. Will do.
Bye-bye.
Thank you. Bye-bye.
Bye.